This is to help you understand your Sirkin Chapter 9, to do your assignment for your 9.1 and 9.2, to understand the formula. What the formula is a T2 sample, as it says for the homework. Now you can tell that this is independent data because you notice the sample size for the X1 is not the same as the X2. See, there's 5 scores versus 6 scores. Okay, we're going to take this step by step, and you're going to see how the formula constructs together. So don't just relax and don't get tripped up over it. Don't get confused. Just do it step by step. Okay, what I do first is add up your X column, which is 10 plus 6 plus 8 plus 7 plus 9 plus 7 is 47. So your sum of your first sample, your X1 equals 47. And then your sum of your second sample, which is 8 plus 3 plus 5 plus 6 plus 7 equals 29. What I notice in here, I constructed my columns different than in the book. I like to put my squared number right next to my regular one so it's easier for me to do it. Since we're right on the chart in the table, I'm going to explain to you how to do the next column before we figure out the mean. 10 times 10 equals 100. This is all this means is your sample 1 squared. That's what that number means. So 10 times 10 is 100, 6 times 6 is 36, 8 times 8 is 64, 7 times 7 is 49, 9 times 9 is 81, 7 times 7 is 49. When you add all these numbers together, you get 379. Again, this is the same data that's in your textbook on page 299. Now for the next one, all this means is the X, it's the square of your second sample. That's what the 2 means, the subscript 2. So 8 times 8 equals 64, 3 times 3 equals 9, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. And you add all this together, 64 plus 9 plus 25 plus 36 plus 49 equals 183. Now we have the information we need from the table to move forward. Okay? So first we're going to do is calculate the mean for the first sample and then the second sample. So what you do again is calculating mean is the same as before, which is the sum of the X, the first sample, over N of 1, which is the total number of scores for the first sample, which this has 6 scores. So for this one, it's the N1 equals 6. Okay? So the total is 47 divided by 6, which is 7.83. Now we go to the second set, the regular X before we squared it, and the sum of that is 29. So notice the sum of that, sum of the X, the second set of data, X2, which is 29, divided by N2, which is 5. Is that 5? Let's see, 1, 2, 3, 4, 5. Yeah, there's 5 scores there. This whole thing here is 5 scores, okay? And that N6, there you go, that's 6 scores. So when you go 29 divided by 5, that equals 5.80. Great, now we can go on to the next part. What this is the S21. What's that saying is this is the pooled variance of the first set of data, because notice the little number 1 is on the bottom there. So what you need then is you need the sum of the X squared 1, which is 379. Notice that goes there. That's all that is. And that you're subtracting by the sum of the X1, which is the first set of data, sum of the regular X before you squared it, which is 47. And that's going to want to be squared. And that's over N1, which is 6. And all of that is over 6. Okay. What we do first is 47 times 47 equals 2,206. Show all of your work, ladies and gentlemen. Show all of it. A lot of professors, if you trip up on a mathematical error, professors will sometimes, you'll get a few more points than if he doesn't see your work. He or she has to see what you're doing. Because we use statistical software now, so our perfect math will be great to have it, but we don't always have it. And since we use software, maybe that's why we get benefit here. But anyway, back to the formula. Okay, we have the next thing what they're going to do is divide 2,206 divided by 6, which is 368.17. Notice I'm working across, I'm writing it all out so the professor can see where I'm going, and that's over 6. So the pooled variance for the first set of data again, so we're at 10.83 because we're subtracting, and that's over 6, equals 1.805. Now they don't have that number in your book, but with writing your homework I think that's really good so he or she can see how you round up. And hopefully don't trip up with that, but if you do, they say, oh, they just have to go back to rounding camp to learn how to round numbers. So that would be equals 1.81. So the pooled variance for the first set of data is 1.81. Now we're going to move over to the pooled variance for the second set of data. That's all this means. The little 2 at the bottom is that's for your second set of data, the pooled variance. So similar thing, but this is for the second sample. The sum of the second sample x squared, which is 1.83, so it's going to be 1.83 minus the sum of the regular x for your second sample. So that's 29, so that's 29 goes up here, see, boom, that goes over here. And that's over n2, which the n for the second set of data, which is 5, so that goes over 5, and all that goes over 5, okay? The first thing we do is 29 times 29, which equals 841. So we write that out, 183 minus 841 over 5, and all that's over 5, equals 183 minus 168.2 over 5. So next we're going to do is show the professor we can subtract, which is 14.8 over 5. That way he or she knows we understand the processes we have to go through to do this. And 14.8 divided by 5 equals 2.96. So the pooled variance for the second set of data is 2.96. This is cool. We have what we need to go on. I have this little in-between thing you don't have to do for your homework, but it's great to understand how to do the F. OBT, that means obtained. How to do the F obtained. So the F equals the pooled variance, the larger number, over the pooled variance, the smaller number. Those are the two things we just calculated. So, which number is bigger? 2.96, 1.81. Ooh, 2.96 is larger than 1.81. So 2.96 goes on the top. That's what this little piece here says. That's the larger of the two, and the smaller one is the pooled variance of the first sample. So it's 2.96 divided by 1.81. So your F obtained equals 1.64. And the next part it says in the textbook on page 278 is your DF, which is degrees of freedom in the numerator. Oh, what number was in the numerator? That was 2.96. That was from our second set of data. So that one had it of 5, the total number. So it's 5 minus 1 equals 4. And the degrees of freedom for the denominator, which remember the denominator was 1.81, that was from our first set of data, which that n was 6, and that 6 minus 1 equals 5. Okay, now that we have that little in-between part is very relevant and important to understand, let's go back to how to calculate your homework. T equals the mean of x1, which is first set of data, first sample, x1, minus the mean of x2, which again, we calculated that at first. And that's all over the square root of n1. Notice I put little parentheses in between. It's just easier for me so I know, hey, I have to multiply this. N1 times the pooled variance for the first set of data plus the N2, which is your second sample, times the pooled variance of that set of data over N1 plus N2 minus 2. That's the same as your degrees of freedom over here. That's like your wiggle room for your data, degrees of freedom. And that's multiplied by 1 over N1 plus 1 over N2. So let's fill these in. The mean for the first set is 7.83. That goes there. The mean for the second set is 5.80. That goes to the right of it. You're subtracting it. And then the sample size, the N1 for the first one is 6. 6 times the pooled variance of the first one. Because they're from the same thing, they like to be together. 1.81, so 1.81 goes there, plus the n for the second set of the data, which is 5, the second set of scores, the x2, times, And then again, the pooled variance for that set of data, which is 2.96. That goes there then, and that's over 6. That's your first set of data, your n, plus 5, minus 2. That comes from up there. And then, right parentheses, and that's being multiplied by 1 over your n1, which is 6, plus 1 over your n2, which is 5. Again, show all of your work. And then you go to this. T equals, okay, first you subtract 7.83 minus 5.80, which is 2.03. And then you go to the bottom part of this. What's 6 times 1.81? That equals 10.86. And then you're adding that by 5 times 2.96, which is 14.80. Oh, I missed showing a mathematical step. I have a 9. Okay, I want to show this. 6 plus 5 equals 11 minus 2. Even though I'm probably not trip up on my addition and subtraction, I want to show it to the professor. Yes. And then for this part, 0.17, where that comes from is 1 divided by 6 equals 0.17, and then 1 divided by 5 equals 0.20. And that equals 2.03 divided by, see, 10.86 plus 14.80 equals 25.66 over 9, which 11, take 2 from that, that's 9. And over here we have 0.17 plus 0.20 equals 0.37. Okay. The next step, that number is, we did everything up top so far, 2.03 divided by the square root of 25 divided by 25.66 divided by 9 equals 2.85. And that's going to be multiplied by 0.37, which comes to a total of 10.545. The number on the top is still the same thus far. Now we got to figure out the square root. What's the square root of 10.545? Which you use your little square root key on your calculator. And if you're wondering how to use that, what you can do is type in the square root of 25. And your answer should be 5. And if it's not, that means you either have to press the square root key before or after your 25. So the square root of this is 1.0286, and I show that number, and then I show the rounded up version of it, which is 1.03. Okay? Then so 2.03 divided by 1.03, this is our t, we're almost there, equals 1.9708. Again, I'm showing the professor this because I'm going to show the professor the full number, and then where I round the number up to, which is 1.971. So our t obtained, remember OPT means obtained, equals 1.971. Yes! Now for the second section, 9.2. How to interpret this to see if it's significant or not based on, I'm just showing for the 95%, which is the P of 0.05. So in your book on page 281, you'll see the T obtained score, and then you will see this other part, which means directional. What it's saying by directional is, in your hypothesis, you'd be saying, okay, these individuals will do better, or your hypothesis say, these individuals will do worse with the treatment, the right or the left of the tail. So in this one, if it's directional, that means it's just you're saying it will occur on one side, which for the 0.05 level of significance, the T crit for our degrees of freedom of 9, which remember, degrees of freedom is 6 plus 5 minus 2, which is 9. For that equals 1.833. Okay, there's the critical value is 1.833, which that number is smaller than what we got, which is 1.971. Oh no! So that means thus the P is greater than 0.05. That's how you write that out. P greater than 0.05. And then that means we failed to reject the null hypothesis. That's what that little abbreviation means, null hypothesis. Now let's look at this data. If it were to be non-directional, which means it could be an either-or thing. They'll either do better or do worse with treatment. An either-or, it can go either ends of the tail. You know, tail, boom, bell curve, either-or, which you're expecting the scores to go like either side. So actually when you look at your little chart, if it's two-tailed, that means it has stuff going on both, it could on both sides. So anyway, back to this interpreting. For a non-directional significant level of 0.05, the T critical for degrees of freedom of 9 equals 2.62. Boom! And you'll see that number again in your textbook. So let's look at this. 2.62 is bigger than 1.971. It's greater than, thus, for a non-directional, cool, the P is less than 0.05, and because it's less than that, we reject the null hypothesis. This is basically your Sirkin Chapter 9, the concepts you need to know for your assignment 9.1 and 9.2.